Number two, a certain type of rocket sled is used to measure the effects of extreme deceleration. The sled reaches a velocity of 320 kilometers per hour, then comes to a complete stop in just 0.18 seconds. What is the average acceleration that takes place in this time interval? Now, heads up, we're going to be needing to use sign conventions here, so heads up. So again, I'm going to make my bank over here on the side of things that I know. I know that my initial velocity is 320 kilometers in the positive direction, which just means forward, right? That's where the sled was going in the first place. And again, you might be thinking, well, the sled had to get up to this velocity first, right? So that can't be its initial velocity. No. Frame of reference says that we're only paying attention to the sled once it's at 320 kilometers per hour, right? So in terms of just kind of common sense, well, yeah, you did have to speed the sled up, sure, but this problem starts once the sled's at 320 kilometers per hour. So our initial velocity is 320 kilometers per hour, and it comes to a complete stop in just 0.18 seconds. So, well, it's at a complete stop. So my final velocity is pretty easy. It's 0 kilometers per hour. And then my delta t, right, so like less than a fifth of a second. Like pretty quick deceleration there. All right. You guys know, again, from your definition that the average velocity of an object is its delta v divided by its delta t, which, again, is simply your final velocity minus your initial velocity divided by your delta t. That's a very, very good division line right there. I don't care what you guys say. All right, so I have 0 kilometers per hour minus, what was it, 320 kilometers per hour. And then here, I am going to do my conversion into meters per second squared. That's just because I want to do that. You absolutely can communicate information in terms of like kilometers per hour squared. It's just that unit isn't used a lot, right? So technically you'd be accurate, but most of your accelerations are going to be in terms of meters per second squared. So I'm going to be doing this this conversion. If you kept yours in kilometers per hour squared, I understand. That's fine. That's fine. That will not affect me grading it at all. All right, so I'm going to convert out of hours and into seconds. And then I'm going to get rid of that kilometer that way. Right, so my hours will cancel, my kilometers will cancel, and so I'll just be in terms of meters over seconds, but then I still have to divide by the seconds here, so that'll give me my seconds squared. Speaking of dividing by seconds, 0.18 seconds, and once I am ready in the calculator, that turns out to be all right, notice the sign convention here. This is a negative number. And yes, if you do not include the negative sign, it is incorrect. Remember, this is an acceleration. An acceleration is a vector quantity, which means it has both magnitude and direction. And so if you do not do something in your answer to indicate direction, right, it's wrong because you're not living up to those expectations of, communicating a vector quantity. Now, you don't have to have used the negative sign. You could have simply said backwards. 490 meters per second backwards. That'd be fine. It's a little bit clunky, but it's 100% correct. Totally fine. Totally fine. Because the acceleration is in the direction opposite of the motion.